Welcome to Brain Vision.
So in this question, we have two waves. Both of them have the same form, but one has an amplitude of 4.6 in the millimeter, and the other has an amplitude of 5.6 millimeter. And they are 0.8 pi apart. We want to use a technique of phasors to figure out what is the amplitude of the resultant of these two waves traveling on the same string. And then what is the phase shift? What is the phase of the resultant wave with respect to the first wave? And then for part C, we have another wave similar to these two waves, but with an amplitude of 5 millimeter. These are all millimeter. And how should we add the third that the final wave has the maximum amplitude possible? So let's first start from part A. For part A, we're trying to add these two together using the method of phasors. So for phasors, we pretty much think of each vector and draw out the first one, y1, is a vector of 4.6 millimeter. I can draw out y2 as a vector of 6 millimeter with 8 pi. Pi is like 144 degrees respect to the first one. This is y1. It would be something like this. So this is 144 degrees. This is 5.6. And then the ym will be, so use our third vector addition technique. We can work out the amplitude. So this distance is 4.6. This distance is 6 minus 5.6 times cosine 36 degrees. Because this 36 degrees and 0.6 cosine 36 degrees is this much. So 6 minus this much is this little line over here. So this is, we need to figure out what this vertical. This vertical one is it's 5.6 times sine 36 degrees square, and the final is 3. So that is 0.29, and we know it has to be millimeter. It is the length of the resultant wave. Ym equals 3.29 millimeter. That's part A. Part B, we're looking for this angle. So in order to do that, what this, and we know what this, we need to do an arctangent. So phi is arctangent 5.6 times sine 36 degrees over 4.6 minus 5.6 times cosine 36 degrees. The result is that angle is around degree, or 88.8. So this is a sum is 2 by 1, 2. And now with y3, that is 5. In order for the resultant to be maximum, y3 has to be in the section in the sum, so that none of the amplitude got in some way dissipated in other directions. So we also, in order to add y3, we also want to aim for an angle of 88.8 degrees.